Hello everyone and welcome to lesson 5. I'm excited to dive into 3D modeling today, where we tackle two crucial commands, shaft and groove. These are the perfect tools for quickly creating circular revolve shapes, a must-have skill in the part design environment. Get ready. Open up your CATIA and let's turn those 3D sketches into professional 3D volume. Let's start modeling.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With Katia, I cut through strife. In my mind, the future's clear. No more doubts, no more fear. Crafting visions in 3D. Katia's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try.
Hello everyone. Today we want to examine the 3D modeling tools called shaft and groove. Many times we want to create a volume whose various sections are circular. In this case, these tools are suitable. I am currently in the part environment. I select a plane and go to the sketcher environment. To draw more accurately, I activate the Snap to Point command. I draw a profile. I want to turn this into a circular volume. I return to the part environment. See if I want to turn a sketch into a revolved volume by rotating it. I must revolve it around a line. Here the only suitable line I have is the V-axis. I activate the shaft command. It is the third command in the toolbar. The parameter settings window for this command opens. This window is called shaft definition. This window has 5 sections and 2 parts. I click on the More button to open the second part. The second part has only one section. On the left side, the first section is first limit. Here, the amount of rotation of the sketch around the axis of revolution in the clockwise direction is specified. The rotation angle is measured relative to the sketch plane. Our sketch plane was the YZ plane. You see this angle value in the box opposite first angle. This value can be a maximum of 360 degrees. Note that this 360 degrees has a condition. Next to the first angle, there is a V symbol. If you click on it, a drop-down menu opens. Other options appear. If you pay attention, all these options were also present in the Path tool. Suppose we set the angle value to 360 degrees. In the second angle section, we can do exactly the same. The direction of the second limit is calculated counterclockwise relative to the sketch plane. It is obvious that the revolution angle of a complete circular shape is at most 360 degrees. The sum of the angles we enter at the first angle and second angle sections can be a maximum of 360 degrees. So, in our example, the second angle becomes 0. In the first section, profile surface is written. Below it, there is a selection option. A framework is seen opposite it. Currently, sketch 1 is named in this box. But if no sketch was known beforehand, this box would be blue and no selection would be written inside it. The sketch button next to it is also for going to the sketch environment. Below it, an item called Tick Profile is seen. If we activate the checkbox in front of it, the second part of the window named Thin Shaft becomes active. In this section, we determine the thickness value. This section is also exactly like the path settings window. Currently, in the framework next to the thickness 1 mm is written. This means that in this case, after creating the 3D shape, we will have a hollow body with a thickness of 1 mm. I want this number to be 4 mm. I double click inside the box until it turns blue. I type this number as 4 mm. I activate the checkbox in front of the neutral fiber. Now, 2 mm inwards and 2 mm outwards from the neutral fiber, the shape will gain thickness. The neutral fiber is also our sketch shape. On the left side and the fourth section, where axis is written, I had to select either an edge of the previous 3D body or one of the axes or a pre-drawn axis. Currently, the only available option for me is the V-axis. I click inside its selection box until it turns blue. I click on the V-axis. Immediately, a preview of the shape is created. Look. The sum of my rotation angles in both directions was 360 degrees. So, I have a complete shape. I click OK. Now I want to see the internal section of my shape. Here, the software has provided a suitable tool for me. This tool is called Dynamic Sectioning. First, I click on this tool until it turns orange. Immediately, you see a red dashed rectangle. The two diagonals of the rectangle are also displayed on it. This rectangle is shown to you inside the 3D shape. Now, this rectangle is parallel to the XY plane. I slowly move my mouse pointer to the edges of the white rectangles that represent the main planes. You see a pink plane with a line perpendicular to it next to the mouse pointer. By placing the mouse pointer next to the edges of each of these planes, the direction of this small plane with its center line changes. For example, now I want to have a view in this direction. Upon seeing the suitable plane, I click. You see that the red plane rotated. Lines also became solid. Now I move my mouse over the edges of the diagonals of the rectangle. Two thin arrows pointing in opposite directions are shown. These arrows show the direction of movement of the red rectangle plane. I move the mouse slowly. You see that the cutting plane moves in that direction. In any state, some part of the 3D body is seen. If I move the mouse over the size of the red rectangular box, again two double-sided arrows are seen. But in this state, by moving the mouse, the size of the red rectangular plane gets larger or smaller. Remember, when you see these arrows, be sure to click and hold the mouse button before moving the mouse. This will turn the pointer hand into a fist. Well, so far the plane was moving parallel to the main planes, but in the middle of the red rectangle, we also have three arcs. If I move the mouse over them, click and hold, by moving the mouse, the rectangular plane starts to rotate. In two of them, this rotation causes the red rectangle to take an angle relative to the initial plane. In this way, we can also see the cut shape at different angles. You see that the cut shape is viewed from non-vertical angles. To exit this state, it is enough to click on the tool again. Everything returns to its original state. This tool is actually a temporary tool. We do not use this tool to prepare a section view. Okay, now I press Ctrl+Z to reach the sketch. I double click on the sketch to go to its sketcher environment. I draw an angled axis. I return to the part environment. I activate the shaft command. An error message appeared. This message says that you can't create a solid body with such an axis. Note that the preview button in the definition window is inactive. I click OK. I activate thick profile. A preview is shown. I click OK. The shape was created. I press Ctrl+Z again. I double click on the sketch. I go to its sketcher environment. I close the ends of the shape. I return to the part environment. The sketch is active. I activate the shaft command again. A preview of the shape is shown. In this case, note that thick profile is now inactive. My shape is a solid body. It has also been revolved around an oblique axis. I give the number in front of the first limit as 120 degrees. I click OK. I rotate the shape in a space to see it's better. The groove command is exactly like the shaft command. You only need to note that to create it, you must first have a volume. I create a cuboid. I go to the sketch environment. I draw a rectangle and constrain it. I return to the part environment. I make it 3D with the pad command. Now I have a cuboid. I select one of the main planes. Note that the selected plane is in the middle of the cuboid. I go to the sketch environment and draw a profile. Note that the start and end points should be in a vertical alignment. I also draw an axis. I return to the part environment. Now you see that the group command is also selectable. I activate the group command. In the axis section, note that the software has identified and selected the axis we drew. Without changing the settings, I click OK. I don't see anything now. I rotate the shape in a space. I see a hole under the cuboid. I change the view to isometric. I click on the dynamic sectioning command. I adjust the direction of the rectangular plane. I select another view. The inside of the part is visible. If you remember, in the first section of the setting window, profile surface is written. Surface means that instead of drawing a sketch, you can select a surface from a previously created body. Suppose we have such a shape. I click on the shaft command. The shaft definition window opens. In the Profile Surface section, you see that the box next to Selection is blue and No Selection is written inside it. Now I click on the curved surface in front of the shape. You see that Complex is written in this box. Now, the box next to Selection in the Axis section turned blue. Here we must introduce an axis of rotation. I click on one of the selectable edges. Here we can introduce one of the edges of the body. Remember, the correct edge must be selected. If you do not select the correct edge, you will encounter an error. A preview of the shape is seen. I click OK. The shape is created. Exactly the same operation can be performed with the Groove command. Well, today's lesson is finished here. Please watch the lesson twice. Practice with me the second time. Good luck. Until the next lesson, goodbye.
Let's build a future.